Okay, so hello everyone. In this video, we will cover types of operating systems. So, in this video, we will cover seven main types: batch operating system, multi-programmed operating system, multitasking, real-time, distributed, clustered, and embedded systems. Among these, multi-programmed and multitasking are particularly important as many exam questions focus on these concepts only. So, batch operating system. Let's start with batch operating system first. As the name suggests, we create batches of similar jobs and give them to the computer for execution. This concept takes us back to the 1960s when not everyone had access to computers like today. Only major organizations like NASA or ISRO, which needed heavy computational work, used this system. Back then, users would load their jobs offline onto punch cards, paper cards, magnetic tapes, like that. Since computers weren't available in every home and were centralized in companies, you had to physically go there with your job loaded on these cards and give them to an operator. You couldn't interact with the system directly. There was no command line or a GUI interface like we have today. The operator would collect similar jobs and create batches. Let's say we have batch B1, B2, B3. The operating system would pick the first job from the batch 1 and give it to the CPU. However, there was a major problem. When a job needed to perform input output operation like reading a file from disk or accessing a peripheral devices, the CPU would remain idle until that operation completed. This was non-preemptive scheduling, meaning the CPU couldn't move the next job until the current one finished completely. This causes significant idle time, and users might wait days or weeks or months for their results. They had to return to collect their output, which would be provided on their tapes or punch cards. To improve this system, monitors were introduced to eliminate the need for operators, allowing user to input punch cards directly. IBM creates a system like Fortran and IBSYS 709X during this era in the 1960s. Now, multi-programming versus multitasking operating system. Moving forward to multi-programming versus multitasking operating system. These two concepts often confuse students, so let me explain them clearly with their key differences. Now, multi-programming operating system. Multi-programming came first and focuses on bringing as many processes as possible into RAM simultaneously. In our limited RAM space, we load multiple processes like P1, P2, P3, and P4. The key characteristics of multiprogramming is that it's generally non-preemptive. When we give process P1 to the CPU, it will execute P1 completely before moving to P2, P3, or P4. The advantage is reduced CPU idle time. When P1 goes for input-output operation, we immediately give another process to the CPU since we have multiple processes ready. Think of it like I am a teacher, or like you can say I am an operator. Imagine there are 10 students in a class, each with the 5 questions to solve. Like one student have 5 questions, another student has also 5 questions, and so on. In multi-programming, I would go to one student, student 1, and solve all 5 questions completely, then move to the second question, no, sorry, second student for all their questions, and so on. A student can only leave if they need something specific, but otherwise I complete their entire task before moving on. So that was multi-programming. Now, what is multitasking operating system? Multitasking, also called time sharing, is preemptive. That was non-preemptive, but this is preemptive. We decide in advance how much time each process gets. If a process completes within that time slot, great, okay, but if not, we schedule it again later. Using the same student example, like I decide to solve only 2 questions per student in each round. I solve question 1 and 2 for one student, and then move to the second student for their first 2 questions, then student 3, then student 4, and so on. Even if one student isn't asking to leave, I preempt and move on to next. The advantage here is response time. In multi-programming, the 10th student waits a very long time for their turn. In multitasking, I reach the 10th student much faster, then cycle back to complete everyone's remaining questions. Multitasking emphasizes responsiveness, giving faster response time to all processes. The system we use today, like our laptops, our PCs, they use multitasking with algorithm like round robin scheduling and all like that. Okay, now moving forward to real time operating system. Real time system focuses on time constraints. Immediate response matter more than anything else. Think of the difference between batch processing and real time processing. For example, when I create and upload a YouTube video, you might watch it immediately after a month or even after years later. Timing doesn't matter, but in YouTube live streaming, when I speak, you hear it immediately. That's real time processing. Real time system have two categories: hard real time and soft real time. Hard real time means this is extremely strict time constraint with zero tolerance for delays. Examples include missile system. If a missile system has a delay and another process preempts, the missile could hit the wrong target. Okay, a critical failure is unacceptable here, so it uses hard real time. And then what is soft real time? Some delays is tolerable without critical consequences. Like examples includes computer gaming, or we can say YouTube live streaming. A 5 or 10 second delay is in live streaming or in gaming is manageable. Okay, this was what? This was soft real time. Now moving forward to distributed operating system. Distributed system spread processing across multiple machines located in different geographical location. I might have one machine here, another machine there, and several other elsewhere, or all connected through a network. These machine works in a loosely coupled environment. Each has its own kernel, memory, disk, and resources. If one system fails, others can handle the workload. Companies like Facebook and Google use distributed environment rather than keeping everything in one location. This provides better availability and fault tolerance. Now, what is clustered operating system? Clustered system also use multiple machines, but they are connected through a local network in same location, like connecting multiple devices in a LAN, local area network. These machines work together as one server or a supercomputer, significantly increasing computational power. The main advantages are increased availability, fault tolerance, load balancing, and scalability. If you need twice the processing power tomorrow, you can easily add more machines to your cluster. Now, what is embedded operating system? Moving forward to embedded operating system. Embedded system works with the fixed functionality. They are designed for specific tasks only. Example include like microwave ovens, washing machine, and air conditioners. The operating system managing these devices is called an embedded operating system. You cannot modify their functionality. A washing machine won't heat food because that's not its designated function. Unlike regular computers where we can change instruction and adjust system capabilities, embedded system maintain fixed functionality throughout their lifetime. This covers all the essential types of operating system. For competitive exam, focus primarily on multi-programming and multitasking concept, because these two are very important. So that's it for this video. We will meet in next video. Until then, bye bye.